Hey guys, I just wanted to do a quick overview here of a edge bander that I've sort of improved on, and it's sort of cobbled together bits of stuff that I've engineered and then bits that I've taken from just industry or already made pieces. But it's a kind of an interesting unit altogether. There's no way I'm going to be able to show you this running and holding a camera at the same time. It's a fully two-handed process. And I don't have anyone here to shoot video, but you'll have a pretty good idea of how it works. So actually we'll start you over here with the feed work. So this is my little bit of designing. Basically, instead of having the roll on flat, which sort of, if you've dealt with the rolls on flat, you know that depending on the driver tension system on them, it's quite easy for a coil to lift up and sort of muck the whole system up because the coil lifts out of the roll and then it's pulling against the center part, and then it binds and breaks or just jams. So I dealt with that. Excuse me while I walk around my table saw here. So I dealt with that by basically making a set of guide rollers, and then this is a spring adjustable arm, and on the end of it is a roller bearing, and then through here these are adjustable. These guys here can be brought in or out depending on the thickness of the edge banding, and they're basically set so they're just maybe you can throw some paper between them and that's about it. And then I made a bearing catch sort of right in the center here. I didn't really know how to get a bearing stuck on the end of a piece of wood like that, so this is what I came up with. Basically it was conduit, and then I reformed it to fit a bearing, and then I have a rod through a rod, which gives me a captive joined nut in the middle, and it lets me set the height of this assembly as needed. I guess once it is set like this, I don't need that anymore, but I wasn't sure exactly where I'd want it for it to run properly. So anyways, it comes up through there, and then it starts doing a curl, and the curl happens off of this roller, and then it goes up through the top roller, which basically takes tension on the curl, and then that 45 and then to the 90. Now the deal with the top and then the 45 and the 90 is it actually takes all the tension out of the edge band and feeds it so that by the time it gets through the upright 90-degree post, it's going in fully centered, and there's just as much tension on the top as there is on the bottom. Now I have it slack right now, so it might not look like it, but when you're feeding it, it feeds straight and true. And that's one of these big problems with these edge banders, is that they don't pull, they don't feed well. The feed mechanism is just these shoes, and there's a lot of room for air in those shoes, and the shoes cannot be tight on the edge band, because if they are, they will induce a lot of curling once the heat hits the edge band, and that creates its own problems. So from there, of course, we have our cutoff tool, and this is nothing that I've made. This part is just off the shelf Freud hot air edge bander, and then it goes onto I guess some sort of silicone freewheeling dolly wheel, and that is the first pressure wheel. The main thing with that is just to get the lip of the board hitting that and starting the glue process. Then it goes over to a drive wheel, and this is a Dayton US made gear reduction, and I made a rubber pulley. I made or I guess a drive wheel you'd say, and then I cut grooves in it as needed, and the traction grooves actually do help quite a bit. The only thing I found is that they have to be perfectly equal, so whatever angle goes this way has to be the same angle that goes that way, or else it'll create a lift or drop into the tape. And then this whole motor is on a tension system. So there's just a simple, I don't remember what they call them, knife hinges or something, but there's a set down the bottom, set at the top, and you can see there's a spring set up in here, and there's actually a little don't know if you can see, there's a little wooden plug I made in the spring, and that, there we go, that that's attached to the motor plate, and that essentially keeps the spring from walking away anywhere. And then you can shim out whatever, just whatever thickness you want. I got a couple washers in there right now, and that's sort of giving it the right tension. Depending on the type of edge banding, you know, you can back it off or add more or whatnot. And then all this stuff is just bracing, just to make sure that throughout this thing's range of motion, it stays completely true, as in 90 degrees. Because if that wheel tilts side to side or up and down, I guess side to side, either way, it'll essentially induce a climb or dive to the tape. And then this block here is actually adjustable, and that block can slide forward or backwards, and that's sort of like a coarse adjustment to the spring tension, and then the washers would be fine adjustment. And so yeah, so the nice principle of this is there's no sort of automatic off-on. You just run the system, run the motor, and when you come and push the board against here, the pressure of pushing grabs the tape and feeds it through at a consistent rate. Idea behind a consistent rate is you get a consistent good glue. And I think that's where most people have a problem, is the inconsistency of the feed speed. They will, and I've done this myself, you know, you might jump forward a bit or you might lag a bit, and it can really hamper the quality of having a consistent glue line. So once the pressure of the board pushes against this wheel, it engages the strip just through friction, and once you're done, or if you're just sitting like this, the wheel just freewheels, because it's not pushing against that edge banding. So it's really simple, but it works. And then we still have the steel plate in the back for cooling, which is quite important on this. It's amazing how much of a difference that makes, having that steel channel there. It just basically cools the glue and the edge banding quite quickly, so it can't move around. And then I have a motor controller in that box, and variable speed with an off-on. And yeah, so that's pretty much the run of it. I just used some melamine countertop. I found, of all the surfaces I was kind of messing around with, I found that countertop was just, it was cheap, and it worked better than everything else I tried. So I have done tens of thousands of dollars worth of work through jobs through this thing, and it's worked just fine. So I'm sure if my equipment supplier sees this, he'll tell me it's time to upgrade my machine, but you know, why not? Why not stick with what we got? So I hope you enjoyed the video, and maybe it gives some of you guys some ideas as to how you might want to make improvements to yours, or not, or however. Have yourself a great day.